5 Newton east and 3 Newton east, resultant will be 8 Newton east. But if you have 5 Newton east and 2 Newtons west, the resultant will be 3 Newtons east. The difference here. Because if this one is east and this vector here is west, you realize the other one is going that way, the other one is negative. Therefore, the sum total here will be 3 Newton east. These are linear vectors. Now, what happens when we take this vector here? If we take this vector here and another vector there, and another vector there, and then we say the vector that is horizontal here is 4 meters. That will be displacement. And this one will be 3 meters west. And then if a person is from A to B to position C, it's like just the person has moved from position A to position C. A to position C, we use an arrow for this vector, and we call this vector R as our resultant. Now, I hope you appreciate that these vectors are perpendicular to each other. Every time you have a resultant vector, you must have head to head. As you can see there, the two heads meet up there. Let's take this one before we go and look at the value of the resultant. Let's take these vectors and see what we can say. Let's look at these 3 vectors and see what we can say about them. This vector is going down, west, south. In fact, this one going east. This one going northwest. Now vector A here, vector B, and vector C. We say here the resultant vector is 0. Why? There is no head to head here. This is head to tail, head to tail, head to tail. No R. R is 0 there. Here we have head to head. Therefore, that is our R. Now, this being a 90 degrees, we can use Pythagoras, which says R squared is equal to the sum of the squares of the 2 remaining sides. The 2 remaining sides is X and Y. Now, our X is 3 meters. Our Y is 4 meters. 3 squared is
9.
9 meters squared. 4 squared is 16 meters squared. The sum of the 2 gives us 25 meters squared. But this is R squared. Therefore, R will be the square root of 25 meters squared.
5.
5 meters, Nana. Correct.
Yes.
We have 5 meters. But because this is a vector, and by its definition, a vector has magnitude and direction, we need to find the direction at which r is moving. Now, if we go back to our Cartesian plane, we have from our Cartesian plane, we will have this. This is west, the north, the east, and the south. So this vector is going that way, is southwest. Or you can also get the angle here. Now, to get this angle here, I said we use the cardinal points or we use degrees, where in physics 0 degrees is here, in mathematics 0 is here. Now, for us to get that angle, we can use what we know, the tangent is opposite over adjacent. So the tangent of theta is opposite. Adjacent means next to, is going to be 3 meters, 4 meters, and that number just comes as 3 over 4, which is 0.75. Therefore, the tangent of theta will be equal to arctan 0.75. What's that in your calculator there? Second function tangent 0.75. That gives me 36.86 degrees. That gives me 36.86 degrees. Now we know we can put that as 86.6 degrees. This is at 36.86 degrees. What is this? What is this? West of south. West of south. This is south. If I move west, I move this way, and that will be that angle there. So I managed to give the amount by division of a vector. A vector has magnitude, which is 5 meters. And then this is the direction at which this is moving. Now, we have a triangle of forces here. We are going to look at another one. This one here, you have a vector that is moving in that direction. And another vector moves in this direction. And then we can say these are two dogs. One dog is pulling in that direction, the other one pulls in that direction. And the angle here, let's say 30 degrees. Now, since you know that a vector can be represented by a line that has a direction, an arrow that shows direction, that's what you should know. The second one is that if this vector A and vector B, you can put a vector anywhere you like, as long as you maintain the direction and the size. Meaning,
Yes.
I can take that vector and put it here. That vector A, I can just put vector A here. As long as the same size with vector A there. Now I have head to tail. That's how we add vectors. It must be head to tail. Now, for me to get R, it must be head to head. That will be my R, head to head. That's my R. The problem is when they say do that with their construction, you use a scale, number one. You use the protractor for angles. Now, what will be the magnitude of this angle here? That's what you should, that's a catch. But that is easy because in geometry, if you have parallel lines, we know that the co-interior angles must add up to 180 degrees. I repeat that. Yes. In geometry, when two lines or three lines are parallel, this angle here plus this angle here are called co-interior angles between parallel lines. Co-interior angles between parallel lines are supplementary. Supplementary, they add up to 180. Supplementary. So if this is the same direction as this, we expect them to be parallel. And if they are parallel, this forms a C shape, which is co-interior. C can face this way, can face that way. C can face that way, they call it an N. It can also face this way, can call it a U. As long as these lines are parallel to each other.
Yes.
As long as these lines are parallel to each other. So if this line is the same direction as this one, they must be parallel. Therefore, this angle here must be 150 degrees because 30 plus 150 give us 180. They are supplementary. Therefore, it's easy for you to measure from this point here to this point here, and that distance you can convert them to meters. Now, I hope you appreciate that. I can also take B and write B here. So I can have A there and write B here. I still have the same R. This is called a parallelogram method. That side you had the triangle, with the linear triangle now is parallelogram method. So you have. And sometimes if you move further, you'll appreciate that I can have a vector A there, vector B here, vector C there, vector E here. Now see what, look at what's taking place there. We call that A, B, C, D, and E. Head to tail, head to tail. But this vector here is a resultant. Must be head to head, and that becomes R. And this one is called polygon. Poly for many. All right. Now let's go back to what we looked at in the morning. I said, if you move from this point here to B, and from B to C, and then if this from here to here, this is B here, and that is C there. And we can move this way. Right. Let's go to simple arithmetic here. We can have from A to B to be 4 meters. You move from A 4 meters to position B, and from B to there is 3 meters. Now, by mathematics, this will be 5 meters by Pythagoras at that angle there. Now, if the time you take to move, if from A to C, the time taken is 3 seconds. 1, calculate the speed. 2, calculate the distance. 3, calculate the displacement. 4, calculate the velocity. I am going to give you these 4 questions that you are going to do as a classwork. And at 8 o'clock, we mark them. We have another class, we mark this, and we proceed. Is that fine?